Video, we're going to be solving radical equations, and we're going to do that graphically. We're not going to do these algebraically today, just graphically. So first of all, let's start off with this word radical equations. What does that mean? Well, here's our definition. A radical equation is an equation, so it has to have an equal to symbol in it, that has the variable that you're solving for, usually an x, underneath the radical sign. And remember, the radical sign was the square root sign. Or it could have been a cubed root sign, or it could have been a fourth root sign. The radical sign just means it's that root sign. All right, so let's start out and solve some radical equations here by graphing. To solve by graphing, when we have an equation, in number one, we have the square root of the quantity x minus 1 on the left, and we have 3 on the right. Typically, when I solve an equation graphically, I'm going to graph the right side of the equation as my first graph. So I'm going to say y equals 3. If I'm in my calculator, it's y1 equals 3. Well, what's 3 look like? 3 is just a plain old horizontal line at a height of y equals 3. All right, then I'm going to graph the right side of, oh sorry, that was the right. Then I'm going to graph the left side of my equation as my second function. So that's y equals the square root of x minus 1. Well, we remember the square root function was the half a sideways parabola. When I put a minus 1 on the inside, that scoots my graph 1 to the right. So my anchor point for my graph is going to be right here at 1, 0. Then I have to plot points. Well, the square root of 1 is 1, so I go over 1 up 1. The square root, here, I'll make a little t-chart for us over here. This is just for a plain old square root of x. So the square root of 0 was 0, square root of 1 is 1. The next point I like to square root was 4. So if I count 4 to the right from my anchor point, 1, 2, 3, 4 to the right, I'll go up 2, and that's where I'll get my second point. The next point I like to plot is the square root of 9 is 3. So from my anchor point, I'm going to go 9 to the right and up 3. I could keep going. The next point I'd plot would be the square root of 16 is 4, but that's really not going to fit on my chart. So I'm just going to start out. I'm going to put an arrow on the right to show that that graph keeps going. Whereas the first point, the anchor, had a solid circle because I could not go anywhere to the left of my 0, 0. I can't take the square root of a negative number. Okay, so what am I doing? I'm looking for where these two things intersect. They intersect right here. The coordinates of that point where they intersect were over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And from my origin, that was up 3. So the intersection point is at 10, 3. But all I really care about is what x values do they intersect, and my answer would be x equals 10. I only want the x values because if I look back in the original equation right here, there weren't any y's in that equation. I put this on the y-axis grid so that I could see it visually, but in reality, I'm only looking for the x value of the answer. Again, I could check this answer by plugging into the original equation if I wanted to. If I plug in a 10 for x, is this a true statement? Is the square root of 10 minus 1 equal to 3? Well, that would mean the square root of 9 was equal to 3, which is true, so I can tell that yes, this is a solution. That way, if I weren't doing it graphically, if I were plugging in and checking, I could solve that way also. Okay, let's go ahead and try number 2. I'm going to solve this by graphing. The left side of my equation was 2 times the square root of x plus 1 plus 4, and I'm going to graph that as my second function if I'm using my calculator. And then the right side of my equation was y equals 8. I'm going to graph that as y1 on my calculator, if I'm using that.
Ms. Tom, please go 6500. Ms. Tom, 6500. Thank you.
Sorry about that. All right, so if I'm plotting this, y equals 8 is a horizontal line up 8. And then my square root function has a plus 1 on the inside that's moved me 1 to the left, a plus 4 on the outside that's moved me up 4. So my anchor point that started normally at the origin right here has moved 1 to the left and up 4. So there's my first point. Now my normal shape, going back to my parent function, would be normally to go over 0, up 1, but in this case I have a 2 out in front, which is going to stretch me vertically, and instead I'm going to go up 2. My next point would normally be plotted from my anchor point, go over 4 to the right, and up 2. So this is where my second point would normally be plotted, but I'm going to double how far I went up, and I'm actually going to go up 4. My next point would normally be over 9, up 3, etc. I could tell this is where they're going to cross. I can see that point on my graph. If I look at the coordinate for where they cross, the x value is 3, the y value is 8. All that really matters is the x value because my original equation only had the letter x in it. So x equals 3 is the answer. If I plugged back in to check it, I would get the left side is equal to 8. And since I was trying to find when it equals 8 on the right side, I know I'm correct. So as I'm moving along, you'll see number 3 down here has me solving 2 times the square root of x minus 1 is equal to 11. Now, for some of these, they get a little bit big to put on my graph paper, or maybe just in the interest of time, I would rather use a calculator. So I've pulled up my calculator here in the graph menu, and I'm going to type 11 into y1, and I'm going to type 2 times the square root. I need to be sure that I only have x underneath the square root. Since I don't have any parentheses, that's fine. If my calculator, if I'm using a TI and it pops up a parentheses to start it, I need to be sure and close it so that it knows only x is underneath that square root symbol and that the minus 1 is outside of there. All right, so now if I draw this, oh my goodness, I've got the square root for this left side of my equation over here. But where is this horizontal line for y equals 11? Well, the horizontal line, if I'm in a standard window, doesn't go up to 11. So maybe what I want to do right now is I need to zoom out. So let me go to zoom, and I'm going to hit out. The same thing could happen on either a Casio or a TI. In either one at this point, it's waiting for me to hit enter to actually do the zoom. So I can tell as I look over on the right side of my calculator here, these guys are going to cross, but they still don't cross in the picture. If I went to GSolve to find the intersection right now, it's going to say not found because it doesn't see where that intersection is. In order to actually get the intersection, let me get that off there, I'm going to probably need to zoom out again, or I could go to my view window and I could just make my X max a little bigger. I'm going to make my X max 50, see if that does it for me. Now I can see where they cross, so I could either zoom out or keep changing my window, and then I GSolve, find the intersection, and they cross at x equals 36. So x equals 36 is my answer. If you needed to show work for this question, you could just sketch a little axis. You could sketch your half a sideways parabola. You could sketch your horizontal line, and you could just give an indication of where they cross. Now they cross at y equals 11, but that's not important for this one. All that was in the question was the x. All right, let's move on to number 4. Number 4, I've got a square root, so that's going to be the half sideways parabola. And then on the right side of the equation, I have 1/2 x plus 1. We should realize that is actually a diagonal line because it's a function of x. So we're not dealing with a horizontal line this time. We're going to be diagonal. So let me go back into my y equals. In y1, I'm going to type 1/2, which I'll write in parentheses. So I put 1 over 22. Get that out of there. 1/2 I'm going to put in parentheses so my calculator doesn't get confused. I always put fractions in parentheses. 1/2 x plus 1. And then in y2, I'm going to put the square root. I need to make sure I put parentheses around my x plus 2 so that all of that is included as underneath the radical symbol. I'm also going to go to Shift View Window Standard to go back to my regular window. And I can see this graph is a little, muddied up. I can tell that they're crossing somewhere around here. I can't really tell if they're crossing over here on the left. So I have a couple options at this point. I could do this on graph paper. If I did this on graph paper, my square root function would be 2 to the left, and then it follows my pattern of over 1 up 1, over 4 up 2, over 9 up 3. And then I have my line, which had a y-intercept of 1 and a slope of 1/2. So from there, that's up 1 over 2, up 1 over 2, or down 1, 2 to the left. So you can see from my graph on my paper here that these do in fact cross 2 times. They cross at x equals -2, and they cross right here at x equals +2. If I want to do that on my calculator, when I cleared my ink off the graph, I G-solve, isect, and you can see it's telling me right now that they cross at -2, and if I just hit the over arrow right here, if I hit that over arrow, whoops, sorry, I'm trying to hit it. Let me delete my circle. Then it will jump over to the second solution, which was when x equals +2. So my calculator can still give me both solutions. If you have a TI calculator, you got to be careful that you actually look for both of them. Okay, so when we have a line and a square root, they might cross 1 time, they might cross 2 times, or they might not cross at all. We'll have that show up in a little bit. All right, number 5 is an example where on the left side of the equation, we may have something that's not very pretty. We have 2 choices at that point. We could either just type it into our calculator, which I've done in Y1 over there, or we could move around some of the numbers and get the square root symbol by itself. Either way, I'm going to start out just by graphing exactly what we had, and when I draw it, I can see these clearly are crossing 1 time. If I do the G-solve, it tells me they're crossing at x equals -1. It doesn't look like they're going to cross anywhere else, so that looks good. If I can't tell what's going on, I may need to zoom in or out. Let's try some other ones and see the other types of graph we get. In one like number 6, where I've got 2 square root functions, I'm just going to have to graph both of those. So I've got the square root, and then I have 6x minus 4, making sure I put that in parentheses again. On the right, I've got the square root of 2x plus 10. By the way, I've switched and I'm now writing the left side in Y1 and the right side in Y2. It really doesn't matter. I was just trying to be consistent with the way we did it with inequalities before, but it's not going to matter. All right, so this one clearly looks like it's crossing only 1 time. I go to G-solve, where do they cross? And I get a fraction, or a decimal. I get 3.5. X equals 3.5, not a bad decimal. If this were a multiple choice, just realize it might have been written as 7/2 or as 3.5. We don't usually write things as mixed numbers in Algebra 2, but any of those could have been fine answers. So be sure if you're multiple choice that you're checking. All right, let's go ahead and do number 7 because that one's a little different. Okay, so on this one, the first thing you might notice is that our variable is now a u instead of an x. That doesn't matter. When I type it into my y equals menu, I'm going to have to use an x anyway. I take the left side in Y1, the right side in Y2. I made sure I put parentheses around what was underneath the square root sign, and now I'm going to go ahead and draw it. Now when I'm looking at this, they're not crossing in my window. If I go to G-solve, isect, it says not found. So what I need to be sure, and when I'm thinking about it, is would they cross somewhere outside of this window? And I can tell based on the shape of them that they're both going to be going up towards infinity, and they're not really going to cross because their slopes are pretty close together. So this is just no solution. There's no real point in me zooming out here. I will go ahead and show you that if I do zoom out, it's not going to do me any good. So zoom out, hit enter, and you can see it's just no matter how many times I zoom out, same thing is going to happen. They're not going to get any closer together. All right, number 8 is slightly different because number 8 is not a cubed root or a square root, but a 4th root. So I just need to be sure when I'm typing that I know how to do that in my calculator. So let me go up and get rid of what's here. In Y1, I need the 4th root. To get the 4th root, I hit the 4 button first, then I do Shift and the caret for an exponent, and then the X, and then on the right side, I had a 3. I'm going to draw this. Let me go back to a view window, standard. And I can see my 4th root is going to look pretty similar to my square root, but it's a little flatter. So I've got this graph right here that's starting at the origin and going over to the right. Although it doesn't cross in my screen, I bet if I move over there, those two are going to cross somewhere. So to find where they cross, I'm going to go to zoom out. By the way, the other thing I could do is I could just start scooting over until I see them cross. That would be another option. Looks like they might be crossing in my picture now. I could go to GSolve isect. It still says not found, and that's because not because they're not crossing, but maybe I just need to scoot over a little more, or I could zoom out a little more. Either way. If it's a multiple choice, you could also look and see what your answer choices were and try and figure out the scope of the numbers that you're dealing with. You could also do this by sort of thinking of the inverse operation. And if you're trying to get x by itself right here, you've got the fourth root of x is equal to 3. What's the opposite of a fourth root? That would be a fourth power. So if we're solving this for x, it's 3 to the fourth power, which is actually a pretty big number. Let me go back in here into my run menu. 3 to the fourth power is 81. So let's go to my view window and see what I have. Right now my x max is only at 65. If I bump that up a bunch and then I graph, let me go back to my graph menu. Now if I hit GSolve isect, I'm going to find it. X equals 81 was my answer. So just realize if it looks like it's going to cross over there on the right somewhere, either keep scooting over until you get it, or think about logically doing some inverse operations and what would happen with those. All right, I'm going to go ahead and cut off the video right here. You have the answers to everything down on the bottom of the sheet. Let's do one first. Let's do number 10 because I want to show you a little trick for this fraction. And then the rest you can just check by looking at the numbers on the bottom. Okay, if I wanted to do number 10, whoops, I'm going to go back to my y equals. And the left side of my equation was the square root. And then I need to put the x minus 2 in parentheses. And then that was y1. My y2 is the square root of 3. Just the 3 is underneath that square root. Then I have to subtract another square root with just an x underneath. So I'm going to go back to a standard window. And I can see they look like they're crossing right here. I can't tell for sure, but it looks like that's what's going on to me. If I go to GSolve isect, I can see they cross right there at 2.083 repeating. So now I've got two options. I can write down 2.083 repeating, but oftentimes I might need a fractional answer instead. So now that I've found this number, I can go back into my run menu, and this would work on either a TI or Casio. This answer was just in x in my calculator, so if I type x, it will come up the 2.083 repeating that I just had, and then I can hit my fraction to decimal button right here to turn that back into a fraction, and that's where my 25/12 comes from. If you had a TI when you were here, you would go to math, enter to turn it into a fraction. You could also, if this were multiple choice, just turn your answer choices into decimals and see which one matches up, but I wanted to show you how to get an exact answer there. So go ahead and try the rest of these, and you've got your answers down there on the bottom to check them. Make sure for some of the ones that have large answers, like number 11, number 8, number 14, those have big answers. Those are the ones where you're going to have to zoom out a bunch to make sure that you can find them.